Hello guys, so welcome to the Dot Crash course, okay? And from here we're going to continue where we stopped in the last chapter. So in the last chapter we talked about patterns, okay, the different ways in which you could destructure them, use them, the use cases, talking about switch statements and switch expressions. Okay, so now we are going to be talking about records, another feature that was introduced into that as from 3.0. So like I said in the previous video, make sure your SDK, your that SDK is as from 3.0 and above, okay, and then you'll be eligible to be able to have access to um, patterns and records, okay. So um, before we dive in, like, what are records actually? So unlike other collection types, okay, that lets you bundle unlike other collection types, right? Records let you bundle objects into multiple objects, right? Multiple objects into a single object, and what you also need to know is that they are fixed size, okay, heterogeneous, typed, and immutable. Okay, so we're going to get into all of that. So and also we need to note that records are real values, like, right? You can store them, you can nest them, you can parse them, okay. You can pass them from one function to another. You can store them in data structures like list, maps, and heaps. Yeah, so that's just that. So let's do the usual dance, okay, where we, in this bin folder, we're going to create a folder called records, okay. So for the chapters we're going to cover, we're going to have everything here. So in this bin folder, we're going to have something called record. Let me close this, open this in the terminal, okay, and create our first example one. So example one dot dot, okay, and we are going to zoom in, okay, so that we can be able to see. Okay, so we're going to zoom in, and I think I'll bring this down, okay, and do this. So for the records, we will first of all start by the syntax, right? So we have something like this, okay, and we can use var, okay, var record, and we can store in some, like we said earlier, we can, it lets us bundle multiple objects into a single one. So we can have here a string, map for integers, and the one for boolean, let's say true, and also we can have another string here saying last or not me, something like that, okay. And basically this is how it goes. So the syntax is that you write them in braces like this type of braces, and you separate each of the fields by a comma, okay. And you need to know that they can be used as return types, as parameters, and so, like, plenty of things, right? So um we could even have a function, just a little function here, saying something like this: init int, I can say swap, okay. Then we, in this case now, we're going to define something like this, okay. So let's just say something like record 2, and they're going to define on the body where we just say var a comma b is equals to record. So here we're destructuring using patterns, okay. So yeah, records 2, and then we just swap and return the opposite, okay. So this is just what we are doing. So let me see what's happening here. So a record type with expression requires commas, okay. Okay, I guess I have to provide a comma here. Okay, so that was just the error I was getting. Nothing really that much. So we could now do something very simple, something very basic, and say something like var record 2. We could have a 10 here and a 30, okay, and we will call swap, okay. We'll call our swap here and just pass in record 2. And if we were to print, let's clear our terminal, and then let's say dart example 1, dot dot. Remember, we are in the records folder. Okay, records folder, and then we get this swapped now. So you see here we had turn, now we have here 30, 30, turn, turn. So we saw another way of swapping using so this is basically swapping, right? Remember when we in the patterns we made mention of that, right? Rather than creating new variables and swapping local variables, right, we just had to like do what we call variable assignment. Okay, so that's that for example 1. Okay, so we are now going to move to example 2. So in here we're going to have example 2, example 2 dot dart. Okay, so now in this example 2 dot dart, okay, we're going to be talking about the two types of records that let me say the two types of field records that exist. Let me put it like that. So we have the positional fields in records and the name fields in a record. So how then do we define positional fields? So it's something like this. Okay, we say string, let's say for example something like this. Okay, record. So this is like the shape or the signature of this particular record. So let's just call it positional. So we know positional record. Okay, and also now for named record, almost like functions, they go inside curly braces. Okay, so we still have these brackets open. Okay, but now we put them in between curly braces as well. So we say int a, for example. Okay, and int b. Now you see here that with this, right, we are providing these values, while here, while in positional we just provide just the types. Okay, just the types are provided in positional, but in named, right, we provide the named records. Okay, yeah, we provide just the, let me say, the fields which are going to receive it, but in positional we just provide the types that we are going to use. Okay, so with that then we can go ahead and say positional record. Say we're just going to pass in something like hello, and then here we're going to have something like 20. Okay, so that's that. And for named record as well, we're going to have something like a, or let's say go again with that O10 and b being, or let's say maybe 10 again. Okay, so this is it. So like we said, right, so we see here named records, and it has this particular signature, right, this particular shape, if I can call it like that, based on the fields, right? So we are able to access it now like this, and like we said, we can store variables in them, pass them to and from functions like we saw, store them in data structures, and so on and so forth. So this is it. So I think I'll just do it in this example. Print, and we're going to have something like this. Okay, now we talk about records. Now records with the same fields, with the same name fields, or which have different names, are different, right, because of the hash code and the equality methods which are produced. So let me just kind of like demonstrate it here. So say we have a, okay, and int we have b, okay, and we have something here like record, let's say ab, okay, and we say it's going to be a, let's go 20, b is going to be let's go 10. Okay, and then we had the same. I'm just going to duplicate this rapidly. So I'm going to say this would be xy. Okay, and yeah, so we're just going to leave this like this. So if we try printing to the console and asking for a record abx is equals to record xy, we're going to get a false. So let's get to example 2. Now example 2, no, there was an error. Example 2. Okay, we're going to get a true. But if the values, I think a mistake if I said if the values are different, right? So if the values are different, then we get a false, right? So we get a false. Just kind of like new to record, so I'm still you need to also get to understand how it works. So that's fine. So if these values are different, then we get a false, right? But you see here that the signature is same, nothing has changed, okay? But as far as we said, as far as the fields, okay, the fields are different, all these values here are different, then we have something different. We could even go ahead and say something like x. Let's go at x and y, okay? Could give here an x and a y, okay? Still use it, and then I'll clear a terminal and we do this. Okay, you see, so we get a false. So as far as these fields are different, okay, this name fields, if this name fields are different, even if they have the same value, okay, it's going to throw to us false. Okay, it's going to throw to us false. But if the fields are the same and they have the same value, then we're going to have a true. Okay, so but if we were to do this, let's say for example, let's just copy this, let me come and paste it down here and do something like this, okay, and paste it here. And what now here we're going to say record cd, and let's just say something like wv, yeah, wv, and we remove this, okay, we remove this, and we also chop this off, okay, so we chop that off, and we do same here, okay. So and if we were to now to do this comparison again to try to find out if record, not like that, if record cd is equals to record wv, we're going to get a true. So if we say example 2, we get a true. So even if we try changing the values, so if we try changing the values, we're going to get if we try changing the values, we're going to get a false. Okay, so for this, it's only valid when the fields, these fields are the same. So if this and this are the same, then it's a true, right? But if they are different, then it's a false. Okay, so we're going to continue now to the next part where we'll be talking about so now we're going to talk about the name fields in records expose getters of the same name, while positional fields expose getters of the name using the $sign. Okay, so I'm going to explain what we mean here. Okay, so let's go to example 3. So we are going to say here example 3. Okay, example 3 dot dart. Now in this example 3 dot dart, we are so we're going to do this, and we're just going to have a person. Let's say we're going to have a person positional record and a person named record. Yeah, let's just do something fancy like that. So we're going to start with person positional. Okay, so we're going to say string name. Let me see if I can do this. So we're going to say string, okay, string, and let's just get the age. Okay, we're just going to get a random age. So we're going to say person positional person positional record is equals to, and then we're just going to provide some random name saying Bob. Okay, and we're just going to say maybe he's 24. Okay, and now we are now going to provide names, so we're still going to go with string name int age. Okay, and here we're going to say person named record. Okay, so close that, and we say name. We can say Austin. We can say age, and then we can say 10. Okay, so now with this, now what I meant by name fields expose getters which are of the same name, it's that when, for example, what I just simply mean is that if we're to store a value, let's say we had something like final name, okay, and we wanted this, let's start with the person named. Okay, we wanted this person named. Now it exposes a getter which is the same as name, such that if we say this, okay, you see we get this is what we mean by these getters, this name and this age, which are the same. So we say the getters are the same name. Okay, so we do this, and we have access to the name. Now if we're to print that, we'll have now the name of that person of this. So we say dart example 3. Okay, now we get Austin, okay, which is obviously this, right? Now for positional expose getters using the name, okay, the name at the $sign position. So it's almost like reading the index of a list, right? Something like that. But let me show you so that you get. So for the second person, we're also still going to get the name. Okay, so we're just going to say name2. Let's just say name2, something like that. Person positional record. Okay, now for the positional record, you see, wait, this is what I'm talking about. So we have a $sign and the number 1. So the $sign and the number 1 just means the position at index 1. Okay, it's something like this. And the $2, it's like the position or the value that's at index 2. Okay, or that position 2. Okay, so if we were to say this, okay, and we had to print name 2, okay, and then we put it here, so we say that example 3, then we get Bob. Okay, we get Bob. So this is just what I meant by it being exposing both positional name records and, did I say positional? Yeah, positional records using the $sign, and name records using the getters which are same as the name. Okay, so let's dive into example 4. Let's see what example 4 holds for us. So the usual dance. Okay, example 4, the dart. Example 4, the dart. So in example 4, the dart, record shape. Like we talked in the previous video, when we talk about the shape, we mean I think maybe I should just put that down as in a comment. Okay, I'll just open that as a block of comment. It's a block of comment or documentation, something like that. So when we talk of shape here, we mean the set of its fields, right? So we mean its fields, the fields type, okay, of the fields type, and their names if in. So when we talk of a record shape, this is what we are looking at: the set of fields, the fields types, and their names if any, right? Uniquely determines the type of a record. So in simple code language, what I'm just trying to say is that you can have a record which, like we said earlier, right, it bundles multiple data types of together. Okay, so that's just what I meant. So it bundles multiple objects together. So let's say, for example, let's go out of the norm a little bit. So we could have here objects, okay, and this object could just have something like pair, and to it we'll just equate something like 42. I'll just equate something like here. So keep in mind that 42 here is an integer, okay, and this norm is like the ancestor of uh, both integer and is the ancestor of integer and double, okay, and the object here is the overall ancestor, so it carries the object, the double, the strings, the list, the norms, okay. So you can read about that on the that documentation to get more insight on that. So that's why you see here we have a string, but it's not complaining because the object is like the ancestor. It's not even, it's like, it's the ancestor of a string. Okay, that's why we're able to input in here. So we could even have a list here. Okay, we could even have a list here of, say, 1, 2, and 3, or 4, 3, 4. So it doesn't really disturb. Okay, so that's just what I meant by that. And we could even verify it. We could verify it by saying print. Okay, we could say pair at position 1 the runtime type. Okay, we could get the runtime type, and the same we could do for pair at position $sign. Okay, position 2 we could get the runtime type, and if we tried printing here, not printing, okay, example 4, if we check it, so we see, you see we get int and string. So we get here int and the string, which is actually confirming what we have here, right? So that's that. So we've talked about the records quality. Okay, so now what about multiple returns? We said we could bundle multiple stuffs together and return them. So like I said, records allow view, as well as you can use them in functions. Don't forget that we said they can be used as return types, okay, and they can be passed into functions. Okay, so records allow functions to return multiple values bundled together. So let's provide an example 5. Okay, that would be an example 5 dot. Okay, now in this example 5 dot, the usual, we're going to have the main. We're just going to have a simple function, okay, that just says user info. Okay, so, and we're going to have something like this. Now records are really powerful in the sense that I think even in Python, okay, in Python we also have records available. I think it was really handy for that to come in with records to available. I mean, that is a modern language, so if it's trying to compete with other modern languages, then it also has to have features that are present in modern languages to help it compete, right? So it's just like if you are competing with someone, obviously you need to have qualities, or you need to possess some qualities that that person doesn't have for you to be able to compete with that person. So that's just that. So you see that with this we could have something like this, user info, okay, and we just pass in something like a map string, okay, dynamic, and we have here JSON, and we have something like this. So and then we could just return also a record saying the JSON, we just want the name, okay, and we could cast it as a string, okay, and then JSON age, and we're also going to cast it as an integer. Okay, also going to cast it as an integer, doesn't matter. So you see with this we're able to do this, like return I think in Python it's called a tuple. Yeah, if I'm not mistaken, it's called a tuple. I don't think it actually has the word records, but I think if I'm not mistaken. But let me know in the comments if if I'm mistaken. But I'm sure it's called in Python. It's called a tuple. So um, you see that with this we're able to return a string and an int. Without records, and we maybe would have used something like a map, right, where on one side we'll be able to hold a string and the other side to hold an int, and try to destructure it using maybe the entries, and it's going to be a lot cumbersome. Okay, but you say that with these records, this actually makes it simpler, very simple. So let's just provide some fake JSON here that's coming from a fake server. Okay, so we have here dynamic, if I can spell. Okay, we have here name, so let's say John, and age, let's say here 45. Okay, and let's say here color, let's say red, let's something like red. Okay, so now what we now do is that we are now going to destructure using a record pattern. Remember, I told you that when we talk about pattern, we just mean like a way of comparing something to another case, right? And which is going to produce a match, right? We saw the constant pattern, we saw the collection pattern. Now we're also going to see something called the record pattern, right? So which it's just what we treated, right? So this is the record pattern. That's why in the previous video I made mention of brackets. I didn't want to get into records because I knew we're going to touch records in this video. So it's just records here. So it's just these brackets, and then we put in here the name, comma, the age, because we said records fields are separated by commas. Okay, and we call in the function saying user info, and we pass in a JSON above. Okay, and let's finish this line of statement. And then with this, now we can now go ahead and print $name, comma, name is $age. Okay, and we could clear our terminal and try to run example 5. Okay, now example 5 we say John is 45, which is what we have here. So it's straight way forward to do it this way. Another way we could do it rather than using the record pattern, okay, would be something like this. Okay, let's just put an or here. Okay, let's say or. So what we could do here is that we could have something like var info. Okay, and this var info is going to hold this user info. Let me just copy this. Okay, so it's going to hold this, and from now this info, if we wanted the name, we're going to say name is equals to info dot the first position $, because we said here, let's just say other name, yeah, let's just say other name. Let me just say other name. Nope, other name. Okay, so we're just going to say other name info, and the same as other age, we're going to have at position in index position 2, something like this. And you see that it's still valid if I'm to print a line here, line breaker, to kind of like separate them when they'll be printed in the terminal. Okay, so if I cut this and I put this here, and we try to print underscore other name is other age. Okay, and we clear and we run example 5, we still get the same thing, right? But this is just too cumbersome. I mean, you want to be able to write efficient, you want to be able to write less code and achieve more, right, with less code. So patterns, that's why I had to get first of all into patterns. So you'll see now that patterns has just simplified the way, or the way we handle it straightforward, okay, by using the variable assignment. Okay, so this is it, and this is all about records. Okay, For better insights, make sure you get to that official documentation for better insights on records and patterns. But basically, I've tried to simplify the explanation so that you could understand what's actually happening here. So that's this, and thanks for watching. Don't forget to like, subscribe, and share. Okay. The in the next video we'll be working out on collections. So stay tuned and don't miss.